Mining. It touches so many aspects of modern life. Without it, materials like copper to carry electricity, aluminum for building aircraft, iron and steel for construction, even ordinary table salt wouldn't be readily available. The average person uses about 40,000 pounds of mined materials every year in products ranging from automobiles to cell phones. As we move to a greener economy, copper and other mined materials will play a critical role in future technological advances. When you start digging into mining, you quickly get a sense of the many technical processes used to produce the materials that enhance our lives. Even though many types of equipment and techniques are used to extract minerals from the earth, the process is easy to understand once you know the steps involved. First, mineral deposits have to be discovered, mapped, and explored. Numerous rounds of environmental, geologic, and feasibility studies are needed to ensure that a mine is economically viable before it's ever started. Massive infrastructure and diverse teams of people must be assembled and deployed, first to build the mine and then to operate it safely with minimal environmental impact. While metals like gold and copper have been mined for thousands of years, it's been said that copper is more important today than at any point in human history, for use in a host of applications like wiring, plumbing, electronics, and green energy applications. Almost anything that involves conductivity and connectivity. Copper mining is particularly interesting and challenging because there are two distinct processes used for extraction, depending on the type of ore involved. In the pyrometallurgical process, copper-bearing particles are first liberated from host rock by crushing and grinding. Froth flotation then separates and further concentrates these copper-bearing minerals. Finally, the smelting process uses heat energy to purify copper by removing iron and sulfur impurities. Naturally occurring copper ores typically contain less than 1% copper. These copper levels must be increased so that smelting can be conducted economically. Copper concentrate from the froth flotation stage is further purified in copper smelters by heating the concentrate to 2200 degrees Fahrenheit. A system of furnaces and blowers removes iron and sulfur impurities so that copper can be cast into 850-pound slabs called anodes that are more than 99% pure. The hydrometallurgical approach, on the other hand, uses chemical energy to leach copper from ore. In some cases, ores are crushed before leaching begins. In other cases, uncrushed or run-of-mine ores are processed. Ore is spread out onto leach pads and an acidic solution is applied. This dilute and impure liquid then travels to the solvent extraction, or SX plant, where the copper is concentrated and purified using special chemicals called chelating agents. The resulting concentrated copper solution is called electrolyte. During electrowinning, the final phase of the hydrometallurgical extraction process, copper-bearing electrolyte is passed between electrodes. Over a period of several days, electric current causes copper to be plated out of solution as large flat sheets called copper cathodes that are 99.999% pure. Which process works best? That depends on the mineralogy of the rock containing the initial copper deposits. For sulfide ores, where copper must be physically separated using heat, the pyromet process works best. For oxide ores that dissolve readily in acid, the hydromet process is a more efficient and cost-effective way to go. Regardless of which pathway is chosen, the end result is the same: finished copper ready for market. In mining, amazing feats of science and engineering combine to provide a host of essential materials on a staggering scale for countless applications and industries around the globe.